Good morning, dear students. I have sent the word file of the grammatic estimations to you today morning. Do you get it? Yes. Now for explanation, I did this presentation. Let us see how that grammatic estimation it works with the barium. This is the second experiment, which is estimation of barium grammatically. The aim of this experiment is to estimate grammatically barium as barium sulfate from the given solution of crystalline barium chloride and free hydrochloric acid. So the solution which is supplied to you, which is unknown, it is having that barium sulfate, barium chloride, free hydrochloric acid, and we are getting the product which is of a barium sulfate to estimate the barium. See, in the aim that one of the spell mistake it happens with me, just excuse me. Uh, Please correct it that to estimate grammatically barium. So barium झाले barium करा BARIUM. So I it remains. Okay, just correct it please. So the apparatus required as it is to make it dilute, filtrate. So the filtration process is there, drying purpose is there, most of washing purposes is there, and that's what the apparatus also we are choosing likewise. They are washing bottle, measuring cylinder, 250 ml, 100 ml volumetric flask, 10 ml, 25 ml pipette, 500 ml borosill beaker, burner, glass rod, funnel, Wattsman filter paper number 41, crucible, oven, furnace and the desiccator. So these are the apparatus that we have to first of all collect in front of you, that we have to when we are performing the practical. Now that oven should be having that 110 degree centigrade temperature. Chemicals which we required for this practical it is, as barium it is in the solution barium chloride twice H2O, it is present with the free hydrochloric acid, and we have to turn itself into the barium sulfate. So what do you and which chemicals we require? Concentrated HCl for the dilution purposes, 2 normal H2SO4 for the reagent of formation of a sulfate, and distilled water, and silver nitrate. Silver nitrate for the what purpose we are using? To remove the chlorine for testing it. Now this is about the chemicals, apparatus and the M. Now what is the principle exactly for this practical? Remember that barium can be precipitated as a barium sulfate by adding hot dilute to normal H2SO4 from remaining solution and way after ignition. So as we are performing the grammatic quantitative analysis practical with the barium, which that solution it is of BaCl2, and we have to take it as a barium only in the form of barium sulfate. So by using the reagent 2 normal H2SO4, that barium chloride, it turns itself into the barium sulfate and it is precipitated out, and that's what we are using this reagent. Now this is the principle or the theory behind this, and the procedure, let us see. First procedure it comes, our first step always with the both of the practical, maybe of iron or barium, we have to dilute the given unknown quantity of solution with distilled water to 100 ml exactly to the mark by using lower meniscus. So students, we are knowing the grammatic estimation, the flask it is of having the mark itself. So we have to if that you are supplied the solution in 100 ml grammatic flask, you have to make the solution by using the distilled water till the mark, that is 100 ml. Shake the flask 3 times by taking precaution. It means while shaking that one of the drop of the solution it will not um, come out or it will not drop. So take care that while shaking that solution that it should be in a proper manner. Pour this solution in a 250 ml beaker. Now use that pipette out, or that pipette which is dry and the clean it 25 ml pipette, and take that 50 ml of the solution by taking the solution 25 ml 2 times by the pipette and pour it in a 500 ml borosil beaker. Now here we are using the borosil beaker, only the reason behind it that borosil beaker has the standard that it will not break it down or crack, and our solution or our practical it will run in a proper manner. So that borosil beaker we will have to take in a 500 ml. That solution 50 ml diluted solution, pour it in a 500 ml borosil beaker by means of pipette. Again we are adding the 50 ml extra solution to make it 100 ml. That 50 ml distilled water which is taken as a 25 ml by the 25 ml pipette again. So that 25 two times solution and 25 ml distilled water. So total of the solution in our beaker it becomes a 100 ml in a 500 ml beaker. Now this is the first and the very careful step of the gravimetric estimation, that we have to take that solution or dilute it in a exact 100 ml by using meniscus. Adding the solution of the distilled water in a solution, the purpose of it only that while we are filtering and while drying and while digestion, all these processes are carrying out, that our barium should not be waste or should not be down, and we can collect all the barium ions in the form of barium sulfate by means of using precipitating agent to N2 normal H2SO4, and that's what that addition of extra 50 ml distilled water it is to be used. Now this is only the technique or smart key of the gravimetric estimation. Now the real practical it is like this. The solution 100 ml which is in your 500 ml beaker, boil it with the addition of 3 ml concentrated HCl. Now the concentrated HCl is the reagent which dissolves all the elements which are to be present in it, or that material which is present in the solution, and that's what we are adding, that concentrated HCl. Then while boiling we keep it on a asbestos sheet, on asbestos sheet, and to this hot solution add boiling solution to normal H2SO4 drop by drop. So we have to add that to normal solution which is a table reagent, take that one test tube to normal H2SO4 and add to a boiled solution drop by drop till all the barium ion precipitated as a barium sulfate. Add a little excess of sulfate, so we have to take care of that all the barium which is present in the solution it should be turned into the precipitate, that is barium sulfate, and that's what little bit excess, maybe 1 ml or 2 ml we have to add it. So only simple practical is there, dilute with a careful manner, add a distilled water, add the concentrated HCl, add the two normal H2SO4 drop by drop till that barium sulfate it forms, and little bit excess, that 1 to 2 ml, to that all that ions get precipitated. Now that digest the precipitate on a sand bath for 1 hour. Now this process it is that crystal from the beaker it should be grow in a proper manner, and that's what we will have that 1 hour to make it a granular crystal. Then transfer the precipitate on a Wattman filter paper. So side by side we have to make that stand, adjust the funnel and make that three-fold paper, three-fold 3s to 1 folded paper which is of a Wattman filter paper number 42. Now last yesterday's presentation I told that the simple filter paper it has that pores they are somewhat bigger, but as the number it is going on increasing, that the pores they becomes very less and fine. So filter paper number 42 it is a fine pored paper, and that's what we are taking it. Before transferring, wash the precipitate 4 times by decantation. It means take that distilled water, pour it on a filter paper where that precipitate it is to be there, and wash by the hot distilled water 3 to 4 times and wash it properly. Filter and wash it on a filter paper with a hot water till free from a chloride. That washing should be tested for the chloride, because we added 3 ml concentrated HCl, and that's what chlorine is present in it, and we are knowing chlorine is actually having that weight which is strong, and that's what to remove that chlorine it is very important step of this one. If chlorine remains as it is in a flask or solution, so it can interfere with the weight of the product also, and that's what we have to confident about, that we removed whole chlorine from the solution, so that we tested that the filtrate from the funnel which comes out by washing purposes, and test with the silver nitrate. If that the test tube, while we added silver nitrate to the filtrate, if it has that curdy precipitate, then we have to wash that again and again, till that by addition of a silver nitrate in the filtrate, it will not have the precipitate. But when that the whitish color it is having that the solution, so just don't worry about it, you can carry the further practical. After that one, as you are confident with it, keep that funnel, keep that filter paper outside, dry the PPT on an air cone, and ignite it in a wet crucible. So before that, before starting the practical also, we have to weigh the crucible as an empty crucible weight. After that one, heat the crucible with the PPT slowly in the beginning, and then strong flame for 40 minutes. The reason behind it, that whole the material, it should be that moisture which is present in it, it should be go out, and we will get that a clear dry precipitate. Cool it on a desiccator and weigh the PPT as a barium sulfate. So while weighing also, you have to take care of, first of all, cool that when we are keeping that precipitate with crucible in a desiccator which has that calcium carbonate and H2SO4, it removes whole the moisture from the precipitate, and it keeps cool the product as it is. After that one, after 5 minutes, you take it out the crucible and weigh it on a electronic balance, that you will get the empty crucible weight A gram, empty crucible weight plus precipitate, that is B gram, and B minus A is equal to weight of the product or weight of the residue. This is exactly very simple practicalities, but if you are to be following in a very careful manner, each one drop of the practical or the solution, it is very important, and you will get that a full of marks. Now this is not again I am saying about the marks, but you will get that a pure form of your product, which will all that industries they needed, and you know, if that purity is there, you will get the economic or that rupees which is in a proper manner. Now what are the observations of this practical? Weight of empty crucible, see, I mentioned here 40 grams, you can take whatever it is. Weight of empty crucible plus product, that is the 14.192 gram, and W2 minus W1, it gives that a weight of the barium sulfate of this practical, or that barium, that is a 0.192 gram. See the reactions what happens in our flask. We are having the solution BaCl2 twice H2O, and we are adding it in concentrated HCl first, and after that one adding that the reaction product reagent, that is the sulfuric acid. So there is the formation of a barium chloride, it react with the sulfate ions, and therefore there is the product which is to be formed, and it settles down barium sulfate and 2 molecule of HCl. So our flask, the reaction it follows like this. So the reaction or that proportional manner for the cryometric factor, it is like this. 1 molecule of the barium sulfate, its weight is 233.42 gram. It corresponds that it has that a barium which has the weight 137.32, and it corresponds how many grams that we have? Barium chloride twice H2O, its weight is 244.32. So that this is the molecular weight of the compounds. Now the factor it comes, 1 molecule of barium sulfate, it corresponds to 0.584 barium, which corresponds to 1.0467 barium chloride. So we are having barium chloride twice H2O. From it we are calculating the only barium ion in the form of barium sulfate. So the calculation it comes, it is like this. Let W gram of the weight of the PPT, that is barium sulfate, equal to 0.192 gram. Now we took that 50 ml diluted solution, therefore it in a 50 ml diluted solution 0.192 gram it is to be there, and therefore 100 ml diluted solution, it comes 2 into W gram 50 ml ला जर 0.192 असेल तर 100 ml ला 0.384 gram. So this is about the given solution. We have that 0.38 gram calculated. Now the amount of barium chloride in the given solution, it is the relation, it depends upon. So 233.42 gram of barium sulfate, which corresponds to 244.36 gram of barium chloride, and therefore 2 W gram of barium sulfate, which corresponds to 244.36 into 2 into weight of the product divided by 233.42, and it comes 0.4019 gram of barium chloride which is present in it. And by the grammatical factor also we are calculated like this. 1 gram of barium sulfate corresponds to 1.0467 of barium chloride, and therefore 2 into weight of the product of barium sulfate equal to 2 into weight into 1.0467 gram, and therefore it comes as 0.4019. This is the weight of barium sulfate which is present in it, and that's what amount of barium which is in the form of solution, that 233.42 gram, which corresponds to 137.36 gram of barium, and therefore in a 2 weight, that W or product barium sulfate, which corresponds to the 137.36 into 2 into product weight divided by 233.42, and thus it comes 0.2259 gram of the barium. That is the B. So this is the simple calculation of barium chloride, barium sulfate, and the estimation of barium which is present in the given solution. It's quite simple. So we have 1 gram of barium sulfate equal to 0.588 gram 884 gram of barium, and therefore the calculation again it comes by the grammatical factor also, 0.2259 gram of barium. So the result comes thrice, that 50 ml of diluted solution gave that 0.192 gram of barium sulfate, and second, it is quantity of barium chloride which is present in the solution, it is a gram, that is 0.4019 gram, and quantity of barium which is in the presented solution, that is 0.2259 gram. Thank you. In kilogram it comes in the 10 raised to minus 3. So this is the practical of grammatic estimation of barium. It's quite easy, but you have to follow in a proper manner. Stay safe, stay home. Thank you. Thank you very much.